Okay, everybody, in my general chemistry 141, and I'm here to make a video for my lecture on the chemistry because we go online teaching, and for the better results for your online learning, and I prefer to give a video recording of my lecture so that you can watch over and over again for review and understanding better. Now I am going to post each clips last exactly 30 minutes on the YouTube and to the public. You can access as long as you have a iPhone or any kind of smartphone. You are able to view it and watch it and review it and understand it. So that's my purpose. It's much better than online face-to-face one-time virtual lecture, then everything's not recorded and then forget about it, and then you have trouble review and understand better. So that's my purpose. Now I will send you the link through email. Check your J number email, and often that's the only way you communicate with each other at this difficult time. Okay? Alright, now let's get into chemistry, general chemistry. We already covered in detail, very lengthy detail, for the first chapter and second chapter. Now we are getting third chapter. You already received my handout. Just sent out to you last week. It's about 4 pages, a simple version, all right? But we already discussed most of the concepts in the past. So we have something left over. We're going to detail today. Now we already introduced, right? What is chemistry, right? And the chemistry, I call it, right? What is chemistry? For those missed my class, did not have the lecture with me for those parts, today is your last chance to review. Now chemistry to me is quite of amazing, and I find out in order to learn solid chemistry, I put parenthesis S behind it. The S stands for the physical state solid. You need to know one product called CHEM, liquid, and another product called IS, it's a gas. Then the last one, TRY, is AQ, representing the physical state aqueous. Now, solid, liquid, gas, and aqueous. That's the 4 most important physical state in chemistry, all right? Now we already talked about this, right? Then in this, it's funny, right? If we check all these reactants right here, this is reactants, right? This is reactants. And then there's the products. That's products 1, products 2, and products 3, right? So one reactants become 3 products. That is a decomposition reaction. It tells the type of a reaction, right? And also it tells the physical state, and also this chemical reaction is completely balanced. The reaction equation is completely balanced because you check every components made by atom, right? For instance, this is an atom, right? Or this is 2 atoms made a compound, and this is a compound. They all fit into the number of atoms on the left as reactants. So this is balanced reactions. And what is the coefficient for balanced reaction? They are 1, 1, 1, 1. Then we don't normally put 1 in front as coefficient. We can omit it, right? And then the direction of the reaction is one way. It's irreversible. Instead of 2 arrow pointing to the opposite direction means reversible. This is irreversible reaction to go one way and never come back. And then normally we put an arrow pointing up right here, right behind the gas, because the gas always evolved and lower in density will be off and into the air, right? Going up. And the solid we normally put arrow down because you're going up because it's a little heavier, dense, and then the precipitate down to the bottom of the beaker in the reaction in the beaker carry out, right? So is this a chemical reaction completely reaction equation completed? Yes, I think so. And also, sometimes on top we put some symbol down there, that triangle representing heating, right? And then you may see PT means use of platinum as the catalyst. Right? Those were written on top of the arrow representing the chemical reaction conditions. You have to, otherwise the reaction won't occur or never finish. It'll take a long time. You never see the end. Alright, so that is chemistry. But really the chemistry defined as what? Chemistry defined as a science or study of matter and its change. It changes. What kind of change? Based on what? Based upon, we call proportionality. Right? What kind of a level of proportionality we talk about in chemistry? We talk about atomic level. Not beyond the atomic, in other words, the subatomic particles. We talk about it, we briefly discuss it, but we do not detail it until very last chapter in the chemistry book called Nuclear Chemistry, and then we will briefly discuss a little bit. But for the first part of chemistry, general chemistry, we do not touch it. So we do not go very detailed in the subatomic particles like protons, electrons, and neutrons. Right? Of course, there's some other even more smaller, deep. So that's that definition, right? And then the chemistry. Now, then what is the matter, right? The matter is a collective term for all kinds of substances, right? Naturally existing or man-made. That calls matter. Now, under that category, we have the rest. So we already talked about, right? So we talk about chemistry. We deal with elements. Now, so far, say it's 120 already discovered. Then let's put 120 of them, right? And the atoms of different kind of elements. You know, each different kind of elements will have their own unique, distinguished atoms as the smallest particle of the elements. They're totally different from each other, but each of those elements will have all their atoms are completely identical, all the same, right? Except different elements. Then under the elements we can have atoms, right? Atoms, right? And then under atoms, now here we have to mention something, all right? In the textbook, they prefer you to use for free online. It's called open text, OPENSTAX. And I find the very first few pages, I find a mistake, all right? Talk about atoms, and this is atom can have a charge. Well, if the atom have charge, we no longer call them atom, we call them ions, right? So atoms are supposed to be neutral, right? And then we have to deal with ions. Now, two different kinds. All right, let me put it here, plus and or minus. Now we call cation or anion. We will discuss in detail and how those can be generated. All right, then we talk about molecules. Right, molecules, right? Different kind of molecule, organic molecule, inorganic molecule based on their compound. And then last, we're going to talk about compounds. Compound. All right, last. Now, we already discussed the elements as we discussed or introduced the periodic table of elements. So under which we talk about the periodic table of elements, right? And we detailed the first 20, right? We detailed the very first 20 elements and their properties, right? 20 elements, and for us to to get familiar. Familiar what? Familiar with their properties. Right? We have a table, right? I think it's page 26, right? On the on my notes, right? You already have a color table and print made up and then design, and for you to use it, and you can go by line the 20, the very first print, all right? And then we gone by the layout of your table, right? And on the left, right, we call it metal. Most of the elements, more than 2/3, are metals. And the remaining 1/3, right? Most of them are non-metals, but within which we have in between the metal and non-metal, we have semi-metal. We haven't got time to talk about that yet. Right? We will get in. We'll get in there, right? So we have 120 elements, right? So there's 120 total. Then I'll say in my notes, I said most of these elements, right? After number 100 were man-made or short-lived, lived milliseconds or microseconds, and then the scientists captured the moment and then did some testing on, find some property of those elements, and they're gone. They're gone, and you have to remake it, right? Regenerate it, right? That's the case, right? So those were after number 100 or 104, right? And now elements, right? Now then atoms, we already gone by those concepts already. So the second one, we're not going to spend too much time on this, right? And then atoms. Atoms are the basic particle of different elements, and the individual elements will have its atoms all identical to each other. But the atom belong to one element will be totally different from the atoms belong to another elements. That's all the same within 120 elements. They're all different elements, will have different atoms. But within all these atoms belong to the same elements will be exactly identical to each other. Do you get the idea? Okay. So atoms, so we have how many types? So we have 120 elements, right? If we have 120 elements, then we will have 120 different types of atoms. Agree? Right? Each one type of atom belongs to one element, right? Right? And but then then we already said then the atoms belong to a certain element are all identical, right? But then the atoms belong to different elements, right? Would be totally different. Right? Clear? Different, totally different. Right. But so what are the atoms? Then under the atoms we should have list a little bit about the property of atoms, right? We already, and then the property of atoms, right? Now we are not talking about just one type, all type, right? All types, right? For all elements, right? Right? So the property, now Then the first one, we have to emphasize that. Atoms of any kind, elements, oh, that's not any kind. Atoms of any elements, just put any element, of any elements, right, are all neutral. In other words, do not bear electric charge. Do not bear electric charge. So neutral, right? It's not, as the book says, atom can have a charge. No, it's not called charged atom. There's no such thing called a charged atom. We already, since it's charged, it's before and after. Before charged is called atom. After charge is no longer called atom. It's called ions, right? So we have to distinguish these two different terms. Otherwise, me understood, but for the entry-level learner like you will be confused, right? Atoms, right? And then B, atoms are the smallest particle chemistry deal with. Now this is not absolute. We're gonna mention that deal with. Now we do deal with some subatomic particles in which proton, neutron, and electron. The electron is the most important part of chemical bonding. So we're gonna deal with their property and their behavior in the chemistry. But what we talk about here is the smallest particle chemistry deal with in, let's put here, in reaction. It's a little bit more specific what a reaction means. In chemical reaction, the number of atoms of different kind of elements will be kept the same, not altered, not increased or decreased. And then they just reorganize with different chemical bonding from the compound as reactants to the compounds or compound as products, right? But the total number of atoms from different elements will be kept the same. That is the whole idea. All right. So this is the atom. We're not finished yet. Let's continue. All right. So let's see. B. The point B tells the smallest particle means what? Means another term. Most of the chemistry or chemists talk about is indivisible in chemical reactions. Alright, so the B can be extended into this, the following. Atom are the, again, smallest, right, particle indivisible indivisible. Yes, right. Indivisible in chemical reactions. In other words, atom small. The subatomic particle, the proton, electron, and the neutron, are going to stay inside atom, not going to come out and split from the atom, right, during the chemical reaction. But you have to have to be careful. Actually, in the redox reaction, the number of electrons change hand to hand between reactants, between the reactant before the products can even produce in the redox reaction. The electron is subatomic particle Yeah, actually, this is a definition was set up a long time ago, not necessarily totally 100% correct, but we're getting there. We're going to specify and we're going to emphasize when the time comes, right? All right. So, and now, first one are neutral. That's kind of important. May have some more. So leave here a little bit, right? So, all right. See, it may have a D, right? We find out, right? Now, then number 3. We talk about here. There's a Dalton's atomic theory and 4 or 5 different statements, and then we're going to brief down there and we'll leave it up. Now ions, right? Right, ions. Now ions, we have 2 kinds of ions. One is called cation and anion. Anions, right? Now, where those cation and anion come from? They come from the atoms, right? Either, right, gaining, or losing electrons. Electron or electrons, or either 1 electron or more than 1 electron, right? To become what? The atoms what? Become charged particle, right? So what is the charge come from? Let's go detail a little bit. Right here, we did not get in there because we getting atoms and try to get into the electron. We detailed and talked about 3D atoms. We remember that before the spring break, I was trying to build an 3D atom with the electron, and we already talked about electron had energy and then spin around so fast, speed of light, like 1/3 or 1/4 of the speed of light. And then within a tiny little atoms, 10 to minus 10 meters, small radius, it has to be so fast. And then, well, they all negative charged, right? Electron only have 2 kinds of electron. One electron, one type spin, self-spin. This one clockwise, the other one is self-spin counterclockwise. Other than that, every other property for all the electrons are exactly identical, right? But the charge, they either gain or lose electron to become charged particle. How this happens, right? So let's put it here, right? A, right? The cation. What is the definition for cations? Right? Cations are the atoms or the particle. This atom, right? Loses its own electron, which is the subatomic particle inside atom, right? And becomes what? Positively charged particle. We call cation. Now that's exactly cation, right? Cation, and for instance, all the metal element, and all metal element with their atoms, right, are capable of forming cations. Now, in other words, let's use a different color. All right, got a few minutes. Different color. What is metal? Yeah, the metal elements form cations. Right? They barely form. I don't think any one of those metal elements will form anion. But then that's the first one. Let's erase down here so we have more room. All right, how this happens? Right, cation. So, example. You have an atom, right? A neutral atom with no charge, right? Is numerically considered zero charged. All right, zero charged. So, but what happened? But electrons are all negative one charged particle. Right? We talk about subatomic particles. We talk about protons, positive one charge, and neutrons zero charge. They both have almost exactly one atomic mass unit as their mass, but the electron is 1840 times lightweight than the proton or neutron, but it's negative charge, neutron zero charge. So if the atom also neutral, it's zero charge, so it doesn't have a charge, right? So, but electrons, then we define the arithmetic operation subtraction as negative sign, right? Minus, right? As minus. As minus. Subtracting as minus. So, what happened to the atom losing electrons? So you have an atom, right? From a neutral atom, which is zero, right? Atom lose electron, lose its electron. Electron is 1 minus, remember we give the symbol 1 minus the charge, right? Minus 1 is the oxidation state. We already introduced its periodicity of oxidation state along the periodic table. We've done this already. We already prepared you for getting here, all right? We've done almost all this preparation for you to get here easily, right? About 35 seconds, all right? And then it's lose electron, and then give you what? So neutral, this is neutral. Neutral atom lose electron. Neutral atoms considers zero, lose considers minus, which is subtract. And the electron is what? Electron is negative 1, right? So give you this operation, 0, double negative become positive, 0 plus 1, that gives you plus 1 as a charge, right? Cancel. Oh. Okay, cancel. Alright, we stop here and then we will continue. So become positive charge cation ion.